water in which we will place the bump calorimeter. Water equivalent of the calorimeter, that is always written on the bump calorimeter. So, initial temperature of the water in the calorimeter is T1 degree centigrade. For example, the temperature today's temperature is 25 degree centigrade. Ultimately, the temperature of water is also 25 degree centigrade. So, when the fuel burns in the calorimeter, the ultimately the heat is transferred to the crucible and to the bump calorimeter. That bump calorimeter again transfer the heat to the water, and the temperature rises from normal room temperature to higher temperature. So, assume the calorific value of the fuel is Q. So, we have taken the mass of the crucible X. So, where the heat goes? The heat is absorbed by the water or by the bump calorimeter or by the water. So, the heat mass is x gram, calorific value of the fuel is Q. So, x into Q, that is heat generated, and heat gained by water is, we know the weight of the water and we know the final temperature of the water, that is T2. So, T2 minus T1 is the raise of the temperature of the water. So, heat gained by the calorimeter is also small w. That small w is the water equivalent of the calorimeter, and the rise of temperature is again T2 minus T1. So, total heat gained is equal to W into 1 into T2 minus T1 plus W, that is the water equivalent of the calorimeter, and the rise of temperature is T2 minus T1. So, we can also write this big W plus W small, that W is the total mass of the water, and the plus W small is the water equivalent of the calorimeter. T2 minus T1 is common. So, that is the raise in the temperature of the water. So, total heat produced by the fuel is x gram into Q, and that Q is the calorific value. So, we can write this equation as x into Q is equal to W plus W into T2 minus T1. So, heat produced by fuel is equal to heat absorbed by the water and by the calorimeter. So, Q is equal to W plus W into T2 minus T1 divided by the x, the known weight of the fuel. So, in this way we can know the calorific value of the fuel. Hence, all the quantities on the right side being known, calorific value Q can be calculated. So, calorific value can be also determined from the Dulong formula. It helps to determine the calorific value if the percentage of carbon, hydrogen, oxygen and sulfur as determined by ultimate analysis is known. So, generally fuel contains carbon, hydrogen, sulfur, phosphorus or other constituents. More we are having other constituents, like for example, if hydrogen is present, then when the fuel gets burned, the heat is produced. But similarly, the hydrogen also burns, it forms the water. the heat that generated by burning the carbon is also absorbed by the water, which is also generated in this equation. So, carbon, hydrogen, oxygen and sulfur stand for the percentage of carbon, hydrogen, oxygen and sulfur respectively. So, if the fuel is having more moisture content or more ash content, then the calorific value is less, and the calorific value is higher if moisture content or waste product is lesser. So, there is a problem based on the bump calorimeter. When a substance which weighs approximately 0.93 gram of a coal underwent complete combustion in excess of oxygen, there is an increase of temperature of water in calorimeter containing the bump. That bump calorimeter is placed in the 1365 and 1365 gram of the water, and the rise of the temperature is 2.40 degrees centigrade. So, if we want to know the calorific value of the fuel, then substance is 0.93 and the calorific value we want to know, that is Q. So, the water is 365 and the water equivalent of the bump calorimeter is 135 gram. So, how we will come to know the calorific value of the fuel? So, mass of the fuel taken is 0.93 gram and mass of the water taken is 1365 gram. Water equivalent of the calorimeter is W. This is generally wrote on the bump calorimeter, that is 135. So, rise in the temperature is 2.60. So, the calorific value of the fuel is 1365 plus 135 and the raise in the temperature is 2.540 and the product of this is divided by 0.935 gram, and by doing this we will get the answer is that the calorific value of the fuel is 3850 kilocalorie per gram. So, generally the fuel which contains again less waste product or water content, it has more calorific value, while the fuel which contains the more waste product or moisture content, it has the lesser calorific value, and the calorific value is the total quantity of heat produced when 1 unit mass is burnt completely in the presence of oxygen in the calorimeter. So, the units of the heat are calories. So, when 1 gram of water is heated to raise the temperature from 1 degree centigrade, the amount of heat absorbed in this process is equal to 1 calorie, and there are some other units are also, that is British thermal unit. So, in British thermal unit, when 1 pound of substance is heated and the temperature is raised by 1 degree Fahrenheit, the total amount of heat absorbed by 1 pound of water, that is equal to the 1 British thermal unit. So, with this, so I am going to finish my lecture. So, again, so there are two types of fuel, that is organic and synthetic. So, on the basis of physical states, there are solid, liquid or gaseous fuels.